New page. Okay, so the units for this is wavelength. Wavelength is lambda. Length measured in meters, we say hesitantly. Yes, meters or nanometers, because a lot of times these are really tiny, so we actually scale it down to a more micro scale. V is frequency, and frequency is measured in two different units of seconds to the -1, and you can write that as seconds to -1 like that, or 1/seconds. Or, anybody have another one? Starts with an H. Yes. Have you seen the Valentine's Day card? Baby, don't hurt me. Okay, thanks, guys. Okay. So, and then C for speed of light is going to be like a rate, and a rate is going to be usually a length over distance, like you travel to school, 100 miles per hour today, right? And so this is different. This one's meters per second, but it's still a distance per time. Is that it for number? Properties of waves include units in your variables. Those are the three main variables that you'll be including. Okay, number 9 now. Will yellow light produce the photoelectric effect on potassium? Sorry, or why will it produce it on potassium, but red and orange light will not? So there are lots of colors of the rainbow, right? Do you guys know like what ultraviolet and IR is? Have you heard of infrared light? Okay, have you heard of ultraviolet light? Yes, UV light is what we call ultraviolet light. Ultraviolet. You can hear that violet part, so you can probably imagine it's really close to the color of violet on the light spectrum. Infrared is really close to red on the EMS, the electromagnetic spectrum. So there are radio waves, which are really long. And then, I gotta go opposite. I gotta go from small to big. I'll memorize them from small to big, not big to small. Okay, gamma rays are really tiny. Gonna X, your voice, my radio. Okay, gamma is really small. X-rays are a little bit bigger. UV is a little bit bigger. Visible, which is the colors that we're talking about, is a little bit. They're a little longer. I'm trying to get them to look longer here. Infrared is a little longer. Microwaves are a little longer. Radio waves are like 10 meters long. Okay, so this is the electromagnetic spectrum. What we're focusing on is, in this case, visible light in this question anyway. So UV is a small wavelength. Infrared is a longer wavelength. So red is on the long wavelength side. Violet is on the short wavelength side. Roy, G, Biv, right? So it's just, I have it backwards up here, simply because that's the only way I've memorized it, sorry. So red has a long wavelength, okay? So it's got a long wavelength. You think it's moving very fast. Kind of slow, kind of lazy, low energy, okay? As you get to the violet side, it's like, okay, so it's going very fast. It's very quick, high energy. And it's not that big of an energy difference, but that difference does make a difference when we're trying to knock electrons out of metals, for example, like potassium in this question. So it said yellow light will cause electrons to be emitted, but red and orange won't. The only thing that we have to pull from here is that the observation that red light and orange light are slower and lower energy than yellow light. Yellow light's on the high energy side of things, and so that high energy just means it's going to be able to knock electrons out of metals. And the picture of that is kind of here. So when these wavelengths of light hit a metal surface, they can energize the electrons in the metal surface so much it pops the electrons out. We feel that as a shock. Okay, have you ever been shocked before? Okay, like you've been walking around like, well, it's like electricity. You walk around Target, shock, you feel the shock. That's because the lights, and there's also friction involved too, are causing electrons to kind of jump out of the metal. So different wavelengths of light have different energy. If they have enough energy, they're going to pop the electron out, like you can see here, here, and here, and that's called the photoelectric effect because it has photons, photons being light, and energy with electrons, photoelectric effect. And we're going to go into that in much more detail, but that's the reason why is because yellow has higher energy than red or orange. That's really it. But I want to tell you more. Okay. So in terms of where is the photoelectric effect used, you see these things? You've seen those before. Fancy calculators. They don't run on batteries. They run on this little light detector. That light detector is just taking in photons, right? So if they stayed in a drawer for days, they would die. Okay, they're taking photons from the area. They go outside or they can be inside, and those photons are knocking electrons around on the inside. And if electrons are able to move, electrons moving is just basically electricity. That's how those babies run. Very cool. And so anything like usually a lot of things with solar energy are going to be related to the photoelectric effect. Okay, reading guide 5 more questions. Ask away, please. Yeah.
Number 9, it says
Whose theory? De Broglie. There's actually like 5 scientists that help with that. De Broglie, his name is kind of, or Planck. Let's see, De Broglie, Planck, Einstein. Who? Huygens? I don't know that one. Did anybody find another scientist for that one? I'll accept many scientists because most of them have some sort of collaborative nature to their discoveries anyhow. But a lot of times it's De Broglie. Okay, more guys? Yeah. Yes. Okay, so a rainbow, let's see, let me move myself a page back here. A rainbow that has red, orange, yellow, green, blue, purple, violet, all together, Roy, G, Viv, all the way there, with no gaps in color. So you might go from like really, really red to kind of a orangey red, and then transition straight to orange, no gap in the middle. That's called a continuous spectrum, because it's continuous. There's no stopping, there's no gaps. And then an emission spectrum is actually a picture that has very few colors being put out. And those colors are actually coming from electrons moving. And if you have hydrogen versus helium versus any other element, every single element has a different emission spectrum. And we call it their fingerprint because it's so different for all of them. But it looks like this. It would be like, actually it would be black on the background. Okay, black everywhere. And then you'd have like one red here and one blue or something over here. So there's gaps. It's all black, and then one emission line, all black, one emission line, all black. I just want to color it all black. All right, guys, another one? Ready. Just fun I've had all day. We just did that for Q's all day, so I know it was really. Okay, pass that ring guide 5 then. And then James will be my main man here. Again, just pass them up and then over. Yeah. If you need a stapler, or if you just dog ear them, I'll staple them for you. And you guys pull out the sheet like this. We're going to do a couple from this little isotope practice. You guys start it, and I'll jump in with you, okay? You guys start this practice. It's not the one we did yesterday. It's on the right-hand side of it. It's got a lot of blank spots, and I want you guys to just do what you can. I want to verify that we're okay with isotopes. Here, if you don't. Is that name? ID? The person next to you will be helpful. Your periodic table will probably be the most helpful. Yes, if you need a calculator. They are right here in my desk. Right? You don't know the A to Z notation? Skip down for just a moment. I'm going to take a picture of this and show you. Focus on chemistry, please, right now. Oh, it's so blurry. What? All right, we all should have our periodic table in front of us. Looking at nitrogen, the very first one, A to Z notation, the way it looks is like this. A to Z, and then your element goes there. It's just a separate way. It's like we did yesterday. We're reading the atomic mass up top, atomic number down low, and then the element there. It's just called the A to Z notation because it's always formatted this way. So for this first one, what's nitrogen's mass? 17. What's nitrogen's atomic number? 7, because you looked on the PTOE for that, and then you just put nitrogen like that. So it's not like anything new. You've actually we just didn't name it yesterday. So looking at the next row, who is this element? How do you know it's hydrogen? Atomic number of 1, so you know it's hydrogen. Okay, so I'm just going to put H and H there. So what else do we immediately know? 1 proton, right? 1 proton because there's 1 atomic number as its atomic number. How would you find its mass? Right, add your proton here and your neutron here. So our mass is 1. So that mass is 1. And then how do I denote it over here in the mass notation? Just dash 1, right? Dash mass is how we write that. And then on the atomic A to Z notation, we have a mass of 1 and the atomic number is 1. So we're flipping around, we're going back and forth because based off what's given, you should be able to find out one thing and it kind of has a domino effect from there. So take a second on the next one. What's your point that's going to be most helpful here? On this next row. Number of protons, who's this? So you're looking for number 11 on the PTOE. You see that sodium is number 11. So put Na there and Na there. Proton number 11 also tells us atomic number 11 because they were the same. How do I figure out neutrons? Mass of 23 minus protons gives me what? So how many? 12. Good. Okay, before we fill out the rest of this, you'll note maybe there's something different about our electrons here. We have 10 electrons here and 11 protons. So we have a charged particle, an ion, right? Is it positive or negatively charged? Positive by 1, because the difference between these is 1. So that's going to be a 1 plus charge. You can denote it on the A to Z notation. Probably more, I don't know, a little easier there. And you can put it over here just for kicks and giggles. And then on there, we also need to denote the mass. So that's dash 23, right, for our mass, because that's what it says here. And then what's our A to Z? 23 and 11. Okay, you guys do the next 2 rows. let's double check these. Let's make sure Emily did her math right. On carbon 14, did we all see this was carbon 14? Yes, because we had a total of 6 protons and 8 neutrons. I think you guys got your 6 probably quickly. That would give us 14 as our total mass. So that 14 was located in 2 locations here. And because the proton number and the electron number were equal, that means it was not an ion, it was just a neutral atom, so there's no charge there. We okay with carbon 14? Okay, the chlorine one, I knew immediately it was chlorine because I had protons of 17, so I immediately knew my atomic number of 17. But I saw electron count was 18, so I knew that it had to have a negative charge by 1, so that's what there's a 1 negative here and here. Did I calculate neutrons right? 18. 17 plus 18 is 35. So 35 is its total mass, so neutrons have to be 18. That really didn't affect anything else, though, just its own self. So you should have chlorine to the -1, so -1 charge, 35 over 17. Who's like 10 to 10 right now? Feeling it. Okay, let's do one more. Are you guys doing them? Actually, let's go down to the second to last one. So it's got the 12, 12, and 10. Oh, I can't see my rows here. Crazy critter. Magnesium, you saw the 12, you could look at the atomic number. 12 protons and the 12 atomic number should match. And then it told us 12 and 12 is our proton neutron count, so we immediately could add those together to get 24 for its atomic mass. And then suspiciously we had less electrons. Well, that means we have a difference of 2, 12 versus 10 is 2. And there's 12 more protons, so it had to carry a 2 plus charge. And then lastly, you just needed to denote the masses here. Okay? So if you're feeling good about isotope, so you will do fine. This is sometimes the part that if you get it, you're good, you're good. You just need to keep practicing. I have a couple extra practices out there for you, okay? So today's class is going to be a little different. I think I'm done with all my review stuff. So in honor of Black History Month, not every department, most departments are trying to do something special to celebrate multicultural education, something related to their discipline. So we are going to do something called the Scientist Hall of Fame. I'm very excited about it. Plus, it's an activity from my grad school. Thank you. Okay, appreciate it. So do me a favor, pull out you can just actually do this on any piece of paper, whatever you want to do on. I want you to take 2 minutes and sketch a scientist. I want you to sketch a scientist. That's the instruction I'm giving you. That's it. It doesn't have to be pretty. Let me hear it. It's fine. It can be my instructions are sketch a scientist. Whatever you think a scientist looks like, smells like, acts like, whatever. It's just small. It's just more for you. I'm just going to look over your shoulder. You can do like what they're wearing, where they're located, where they're friends, not. about a minute more. All right, something just shout out, a characteristic that you maybe indicated on your illustration. Go for it.
A mustache.
Mustache. You must have a mustache. What else? Lab coat. What keep going? Crazy hair, glasses. Science stuff. Glass speaker.
Yeah.
Lab equipment. What else? On the side. What gender did you draw? Male. Raise your hand if you did male. Raise your hand if you did girl, female. Okay, unknown. Okay, so that was interesting. That's her. I heard a lot of lab coats, saw a lot of crazies. It's kind of crazy. Einstein here. What race were they? I don't know. They were paper race. Okay. Black, white, Hispanic, Asian. Did you decide, or did you just kind of blindly go with the drawing first? If you had to assign a race, what would you have signed it? Probably something like this. Look at all these white guys. White guy mustache, glasses, tie, tie, tie. One lady, Marie Curie. Okay, one lady. So what you can probably tell is that we're talking about like what is science, who is science, and why are they science? Why are they assigned to be the poster child of a scientist, and why are other people not? So there's been a lot of things that happened through history that have controlled who made progress in science and who has not. Some of it's religion, some of it's politics, some of it's just society and who favors this about society and who favors scientific progress and who favors making another maybe your economy stronger versus innovation. So there's lots of things that have played into historical development of the sciences. And sciences, I'm expanding them to be STEM. Okay, so science, technology, engineering, and mathematics. So what I'm going to have us do is kind of explore a little bit more and figure out why this person was recognized for their scientific accomplishments and contributions to the world. This person wasn't. Okay, so there's a big document on my website called the Science Hall of Fame. And so what we're going to do is we're going to kind of look into why were specific genders recognized or not recognized, cultures, races, ethnicities, religions. Anything could have been the qualifier of why they were recognized or why they were not. Okay, so this might be something you're very comfortable about talking about. This might be something you're like, oh my gosh, I've never said this out loud before. But it's fine. Just I want to talk about it. And this is going to be something that maybe helps you appreciate why things are the way they are and not take it for granted. So some scientists from different populations, specifically outside of like the Western world, were marginalized because of something going on in their world, in their culture at the time. I mean, they maybe were recognized, maybe they weren't. Maybe they were like, you're a girl, you probably shouldn't do science. Or you don't look like the rest of the scientists in our crew, so you're not allowed to join our crew. So I want you guys to look into that some. What you're going to do, and so this was interesting, this is really why made me think of this. I went and saw Neil deGrasse Tyson in October for my birthday, and he showed me this, and I was like, wow, I didn't know who actually discovered every element on our periodic table. You see a lot of USA, okay? You see some United Kingdom, mainly white people. Sweden, white people. Germany, white people. Russia, white people. Italy, Finland. There's nothing else. And that's kind of a shame because somebody has influenced one culture to do so much more in STEM and not another culture. And it may not have been an option. It may have just been something that was different about their economy, their politics. But we have a lot of more people representing the world than just this. So this was really interesting, and I want to share that part with you. So what you're going to do is you're going to select a scientist, and you're
you're going to initiate them into the Science Hall of Fame. But I want you to think about who you're going to be recognizing. And there's some different cultures, different races, different genders you can recognize. And there's many things you can explore. I have a bunch of links for you. So consider some diverse individuals as best you can and educate us why they should be recognized because of their contributions to the world. So you're going to make an infographic about this person. Who's ever made an infographic? Some of us are familiar with this. It's just going to be like a poster that's related. And there's easily pick a chart, Canva, Vintage. There's a lot of different sites you can use for that, or you can just make it on Google Doc and just use the drawing feature and input things and connect it. And I'm going to submit our infographics to the American Chemical Society Infographic Challenge, which is due on February 15th, Monday. Okay. So I'm going to try. Maybe we'll win something. You guys will win something. I think it's a monetary prize too. So some things that you can, right? Oh, I'm pretty excited for you. Some things you can consider are anything science, chemical engineering, food production, material science, which is new, biomedical engineering, computer programming, mathematics, anything. Yeah.
So it doesn't have to be necessarily chemistry.
No, you can recognize anybody for their contributions as long as it made something better in the world, the global world. Okay. So a couple more things. Things I would like on it are, how do you choose your person first? I want you to choose somebody who has one characteristic that is similar to you and one characteristic that is not similar to you. Okay? So me, I'm a white female. I might choose a black male. Or I might choose that would be two differences. I would choose a black female. Okay? You can be whatever characteristic you want, similar and different. And if you need some help with what's different between race and ethnicity, I have a link here for you. What do I want on the poster? What was their accomplishment? How did they do it? Did they work with somebody? Were they recognized? Yay or nay? So did they receive any credit? And if they were not recognized, why? Something about the history at that time. And if they discover something, made some sort of scientific contribution, tell me what was the impact in the world. You might include a little background there, but not a whole lot. Okay, so that's basically it. You can add pictures, you can add a lot of other things, but that's the minimum. So I'll leave you with one thought before we jump into this. Yes. What do they have in common, people? What do you see? What do these see? Okay, they're all in dresses. They're all females. They're all African American, and then we have the man who knows it. Good. They're all astronauts. Okay, so when you see something, you don't know what you're seeing until you actually think about it. They're all astronauts. Okay, so think kind of beyond what you're seeing and dive into it. Learn something about another culture. Learn something about somebody else. Grab your laptop and jump right in. It's on YouTube too. Okay? Now, I knew you would be the one. I knew you would. I'll pull this up. Oh, you guys will sign up for your person. I'll show you where it is on my website. I don't want any doubling up. I have there's a list over there. So all look for third period. Look for your name. And you'll see using you're not really working as a group until you're doing this or share out. It's just, it becomes like a dividing group for you versus you looking up everything we're all scientists. You look up for like my girl's in the back. I'll grab it. I know. Use the desktop right now. Yeah. There are a lot of links on the document that are at the bottom of the document. Science Hall of Fame document. They are very informative. They're on the bottom. Sites for inspiration is what I call them. I also have these little cards back here that have these are females in science. That's what you kind of study. If you want to look at any of these pictures and cards, if this is the characteristic that you're interested in, add it. Just don't take them. I might need up for another. Who has number 5 laptop? Who's number 5 laptop?
I do.
If you don't know your number, it's on the wall. tried to find as many sources as I could, but do whatever you are interested in. Okay, make it so that you're learning something that's new. Right, so I see the technology coming out on like your technologies. My rules here, because some of us get very distracted. We don't have any willpower. Make sure if you're putting music in, that's totally fine. Put your phone in your pocket or something, or turn it over so you're not distracted. Because we all know if somebody texts us, we're going to check. We have no willpower against it. It just happens. I do the same thing. Like during a staff meeting, like, well, email. Okay, so turn it over so you can't see it. So you're staying focused for the next hour, or a little bit less than an hour. If it's not connecting, go to this side of the room. And I have So after you have selected your person, you guys look up here for me real fast. After you select your person, you're looking in the Science Hall of Fame document. You kind of do a little basic research. You're going to look under the unit. The homework page. El Homeworko. Here we go. And it says Science Hall of Fame sign up. And when you click that, it's just an Excel sheet. You're just going to put your name in and who you selected, so that I know and you know and everybody else knows. Okay, so choose your person and just start doing your basic research right now. Design as much as you can. No, that was just, I had those cards, so I was just showing those as another resource. I'm going to try to have somebody from UNC Charlotte come talk to us about their research as our celebration of this.